All right, right triangle trigonometry. So we're going to do SohCahToa stuff today. You may be right, Pythagoras, but everyone's going to laugh when you call it a hypotenuse. I mean, he's not wrong. Like, there's so many jokes about hypotenuse, but we don't need to get into that. Trig ratios and Pythagorean theorems can only be used on right triangles. That is so important to remember. We're going to get into how to solve triangles that aren't right triangles, but remember that you can only use the trig ratios and Pythagorean theorem on right triangles, okay? Okay, so if we're given, this is just like some notation thing, but if this is angle A, this would be side A because it's the opposite side from A, okay? If this is angle B, this is side B, and this is angle C, so this would be side C. Okay, and if we're working off of angle A right here, this would be the opposite side. The adjacent side is the one right next to it. And then the hypotenuse, or hippopotenuse, oh my goodness. Okay, is the longest side. Okay, or the opposite side, opposite right angle. And this should be review. You should know this, but it's good to talk about it, okay? So let's get into solving this. Side opposite. Opposite side is opposite of the given angle, duh. Adjacent side is next to it, and hypotenuse is the long side. Okay? These names are specific to right triangles. Do not use these on other types of triangles. That is very important. And every single year, I say this, and every single year, people try to use Pythagorean theorem on triangles that are not right triangles. Okay? Oh, boy. Okay, Patrick. Let's go. There's an easy way to remember how sine, cosine, and tangent works. And if you just remember SohCahToa. So sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so let's look at this and let's find the side lengths of this. So given that angle right there, that is the opposite side, and that's the hypotenuse, which means that I have to use sine here because I'm given the hypotenuse. I'm trying to find the opposite side, okay? So this is going to be sine of 64 is x over 25. And then I could, yes, make sure your calculator, this is like the most important thing right now. Make sure your calculator is in degree mode. If your calculator is not in degree mode, you will get every single one of these answers wrong. Okay, please make sure your calculator is in degree mode. So then here, I can put that over 1 and just cross multiply. So then I have 25 times sine of 64 equals x. Then if we just put 25 sine of 64 in your calculator that is in degree mode, we will get x is approximately to 22.47. Okay, let's do another one. So this one, we are given the adjacent side and the hypotenuse. So we're going to use cosine. So this is going to be cosine of 18 is x over 34. Can put that over 1, cross multiply. So that's 34 cosine of 18 equals x. And then just put it in our calculator. So x is approximately 32.34. Which makes sense. Like, it looks like it'd be about 32.34. If I had a guess, I would have guessed 32.34. I'm just kidding. Okay, next. Here we have opposite and we have adjacent. So this is going to be tangent. So this is going to be tangent of 35 is opposite over adjacent. I don't know why I put that over 1, like right at the beginning, but it's okay. So tangent 35 is opposite over adjacent. Now the x is in the bottom, which changes things a teensy bit, not too bit. But let's cross multiply it. So that's going to be x times tangent of 35 equals 9. So then I'm going to divide by the tangent of 35. So x equals 9 divided by the tangent of 35, which again, just put it in your calculator that is in degree mode, and you get approximately 12.85, which would have been my guess. I'm just kidding. Okay, cool. We good with that? Now let's find angle measures, okay? So angle measures, we have to use the inverse to find the measure of the angle. So basically, if sine of theta equals x, then theta equals sine inverse of x. And same with cosine, same with tangent. So let's just kind of like work through the math of this. So sine of theta equals x. Well, if I just apply the inverse to both sides, so then I do sine inverse of sine of theta, and that equals sine inverse of x. Well, if you know anything about inverses, that will just, on the left side here, this sine inverse and the sine basically cancel each other out. So that's why we're left with theta equals the sine inverse of x. Okay, and same thing with cosine, same thing with tangent. Okay, and it's okay if you're like, I don't know anything about inverses. We have a unit on it later. Okay. Anyway, so, oh, look. Well, the sine function takes an angle and gives us a ratio. Okay, so this is called the inverse sine. It goes the other way, but it gives us an angle instead of a ratio. Okay, kind of what I was just explaining. But, all right, so if we're given this and we want to find theta, well, we're given the opposite side and the adjacent side. So that must be tangent. So that means tangent of theta equals 8/14. But then I have to do the inverse of both sides. So then I'm left with tangent inverse of tangent of theta equals tangent inverse of 8/14. So theta equals tangent inverse of 8/14, which means if you put that in your calculator, the way you do the inverse, it's the same place that the tangent button is, but instead, well, that doesn't even look like tangent. So tangent, you just push second tangent, and that will give you this inverse button right here. Okay? All right, let's do this one. So here we're given adjacent and hypotenuse, which would be cosine. So this will be cosine of theta equals 38/40. Take the inverses of both sides, and we get theta equals cosine inverse of 38/40, which is approximately 18.2. Which makes sense. That angle looks like it's pretty small. It's probably about 18.2. Okay, here, so that's the opposite. That's the hypotenuse. So this is going to be sine. So this is sine of theta equals 17/22, which means theta equals sine inverse of 17/22. So theta is approximately 50.6. Cool? All right, this is the last thing we're going to do. So we're going to talk about angles of elevation and angle of depression. So we think about like, okay, we have this dog down here, and we're going to name him Aldebaran because it's my dog. Little Aldebaran. So Aldebaran is looking up at this bird because he's obsessed with birds, and we'll call this bird Penelope. Yep. My cousin has a dog named Penelope, but it's a bird now. Okay, so this angle of elevation, so wherever the dog's eye line is, and he looks up, so he's looking up at the bird, that is the angle of elevation. Okay, but oppositely, like, say the bird's looking down at the dog, like, do not try to attack me, like, because, I mean, he wouldn't attack, he just, like, is like, what is that bird doing? She's so pretty. But anyway, so the eye level is here, but then it's looking down at the dog. So that is our angle of depression. Okay. And let's get into some story problems. So the angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. If the top of the lighthouse is 161 feet above sea level, how far is the boat from the lighthouse? Well, let's first visualize what the heck is happening. So we have this boat, and we have this lighthouse, okay? And the angle of elevation from the boat to the lighthouse is 5 degrees. Okay, and the lighthouse is 161 feet above sea level. So we just created a triangle here. Okay, and we need to see how far is the boat from the lighthouse. Well, that is this measure right there. Okay, and this is a right triangle. Just because we constructed it that way. Okay? So then this is going to be tangent of 5, because we're given opposite and adjacent. So tangent of 5 is 161 over x. Put that over 1, cross multiply, so we get x tangent of 5 equals 161. So divide by tangent of 5, x equals 161 over tangent of 5, which means x is approximately 1,840.2 feet away from the lighthouse. Okay? So this one, a fire is spotted from the top of a 125 tall fire tower. If the angle of depression to the fire is 19 degrees, how far is the fire from the base of the tower? So tower, fire, and here's our triangle. Now, the tower is 125 feet tall. The angle of depression here, and this is where you have to be careful, is that angle right there. Okay, so the angle of depression is 19, and then that is x. So there's a couple ways we can go about this. I'm getting ahead of myself. So how far is the fire from the base of the tower? That's where we got this x from. So we could, if we wanted to, and this is one way to solve this, is we could go like this. And this length is the same as this length. So that could be our x. And then this length, let me get a different color. This length is the same as this length. So this could be 125. And then there's a triangle that we could solve if we wanted to. Okay? Or the other way to do this would be to, well, we know that these ones right here add up to be 90 degrees. Because of the way it's constructed. So if we just do 90 minus 19, that gives us 71. And then we could just use that triangle. Okay? So either way, you're going to get the same answer. It doesn't matter. But I think I just chose to do it that way. So from that angle, I'm given opposite and adjacent. So that's tangent of 71 equals x over 125. So 125 tangent of 71 equals x, which means x equals 363 feet. Okay. Oh, I didn't even put a goodbye thing on here. Sorry, guys. I'll just put it on here myself. Goodbye. I love you. Just in, like, the most innocent, like, I love teaching you guys. Thank you so much for giving me the opportunity. Goodbye. Oh, wait. Stop. Sorry.